All right, so this is section 9.3, find special products of polynomials. So first thing you need to do is pause your video and write down the square of a binomial pattern. And this is whenever you take a binomial and you square it, you're always going to end up with a squared plus 2 times a times b plus b squared. And the end is always going to end up looking like a perfect square. And we will practice that and learn more about that. Okay, so our first example is x plus 5 squared. So we're going to follow that same pattern that we just wrote down, that square of a binomial. So it's going to end up being a squared plus 2ab plus b squared. Okay, so this would be your a, this would be your b. So first term squared would be x squared plus, and then we're going to take 2 times a times b. So a times b is 5x, and then plus our b squared, so 5 squared. Okay, so then we're going to simplify that. So x squared plus, this will become 10x plus 25. And you could jump straight to this, that's okay. So the idea is to know this pattern so well that you can go from here to here. And notice that this is a perfect square. Those are always going to be perfect squares at the end. Okay? So this is essentially the same exact thing as if I were to go like this and FOIL. Because squaring something is taking it times itself. So I could FOIL and get the same exact answer. It would just take me longer. It would take me longer than memorizing this pattern. Okay, but foiling will also get you there. But the reason we want to memorize these special patterns is because when we go to do factoring, which is when we're going to go from this answer up to this answer, we want to memorize these special patterns because that's going to get us to be able to factor quickly. Okay, so we got to kind of crawl before you can walk, or whatever, however you would like to word it. So x plus 3 squared. So we're going to do the same thing. We're going to square the first term. Then we're going to take our 2 terms and multiply them. So it'd be 3x. And then we have to take that times 2. And then square the last term. So x squared plus 6x plus 9. And again, notice you have a perfect square at the end. Okay. The next one is a square of a binomial pattern. I want you guys to write this as difference of squares. Why would I call it difference? What does difference mean? Subtract. Notice that this is the same thing, except this is a subtraction and this is a subtraction. So that's why I called it difference of squares. That's how you're most commonly going to hear it referred to, as difference of squares. So you have the same exact setup, the same exact pattern, except you have a minus. You have a difference. And the only sign that's going to be a negative in the end is going to be in front of your middle term. Okay, so here we have, same thing, we have a binomial, but this time we have a negative sign or a minus sign. So we're going to take the first term and square it, and then we're going to have a minus 2 times a times b. So this is kind of tricky for some people. We're not going to take negative 9 times x. We're just going to look at this like b is 9 and a is x. So it's going to be just a 9x. So don't do negative 9x, just do 9x.